So to calculate the value of this 1 plus I whole power 6 into plus 1 plus I whole cube, let us write this 1 plus I whole power 6 as 1 plus I whole square, the whole cube. And this one direct formula we have, so we can write that expansion. So first 1 cube 1 minus 3 times of 1 square into I plus 3 into 1 into I square minus I cube, because A plus A minus B whole cube formula. This is 1 plus I square is minus 1. This becomes 2I, the whole cube. And I cube is, I square is minus 1, the minus 3 and plus 1 is minus 2. And this is I cube is minus I, minus plus I, minus 3I plus I minus 2I. And I cube is again minus I. So minus 8I minus 2 minus 2I. So the minus 2 minus 10I. That's the answer. They have given x plus I by the whole power 1 by 3 equal to a plus I by. They're asking us to show this. So if you see in this equation that you need to show, your x and y appeared only once. So if you get the values of x and y, then it is easy to prove that. So x plus iy equal to a plus ib the whole cube. And just now we used that formula of the first one cube plus 3 times the first one square into second one plus 3 times the first one into the second one the whole square plus the second one the whole cube. So this a cube and minus 3ab square, and in these two, if you take the I common plus I into and 3a square b minus b cube. So if you equate the corresponding real and imaginary parts, you get x equal to this one. In this, take a common because you are looking for x by a. So a square minus 3b square. And y equal to, in this, take b common because you're looking for y by b. So the 3a square minus b square. So that implies x by a equal to a square minus 3b square, and then y by b equal to 3a square minus b square. Because the LHS is the difference of those, just subtract the second one from the first one. Then the a square minus 3b square minus 3a square plus b square, which is equal to minus 2 times of minus 2a square minus 2b square, which is equal to minus 2 times of a square plus b square, and that's the answer. So you just substitute x plus iy in place of z. So the x plus iy the whole square equal to z bar is x minus iy. So convert the LHS also into the a plus ib form. X square plus I square y square plus 2ixy equal to x minus iy. So equate the real parts, the x square minus y square, this is I square is minus 1, equal to x, and 2xy equal to minus y. And now if you, second one is easy to solve. So if you bring the y to the LHS and then take y common, the 2x plus 1 equal to 0. So the y equal to 0 or 2x equal to minus 1. That is, directly you can write x equal to minus 1 by 2. So in case of y equal to 0, case 1, you substitute this in this, y equal to 0, x square minus 0 equal to x. So x, bring x to the LHS and take common, x minus 1 equal to 0. So the x equal to 0 or x equal to 1. That means 0 comma 0 is one answer, 1 comma 0 is one answer. Next, you go with this x equal to minus 1 by 2, substitute in it. This would be 1 by 4 minus y square equal to minus 1 by 2. So 1 by 4 plus 1 by 2 is 3 by 4 equal to y square. So y equal to the plus minus root 3 by 2. So the other 2 points minus 1 by 2 comma root 3 by 2 minus 1 by 2 comma uh, minus root 3 by 2. So if you need to write the answer in conclusion in the complex number form, so solution is 0 plus I0, 1 plus I0, and then minus 1 by 2 plus root 3 by 2I, and minus 1 by 2 minus root 3 by 2I. So to get the imaginary part of this, you just substitute x equal z equal to x plus iy, and you need to convert this into a plus ib form, and the b should be equated to this -2, and you get the locus. Multiply the denominator with its rationalizing factor. So we just multiply those, and then they told that the imaginary part is -2. The imaginary part is this one by this equal to -2. That implies, so the minus 2x square minus x plus 2y minus 2y square by y square minus 2y plus 1 plus x square equal to -1. So the minus 2x square minus 2y square minus x plus 2y equal to minus x square minus y square plus 2y minus 1. So bring that minus x square to this side. So this minus x square minus y square, and the 2y get cancelled. Minus x plus 1 equal to 0. And this is -2. That's a mistake. So then everything becomes 2 times. So -2 to -2. This is 4 and this is -2. So then that directly these will get cancelled. This, and this get cancelled. This y won't get cancelled. You'll remind that -4y comes this side, minus x minus 2y plus 2 equal to 0. It's just line equation. That's what they're asking us to prove. Prove that the locus of z is the straight line in the organ plane, and then this is a line equation, hence prove. Same as the previous one, you write the x plus iy the whole square minus 1 the modulus equal to x plus iy the mod the whole square plus 1. So this is x square minus y square minus 1 plus 2xyi equal to, this is x square plus y square plus 1. This is squaring on both sides. You get under root, you get the square on both sides. And then you get x square minus y square minus 1 the whole square plus 2xy the whole square equal to x square plus y square plus 1 the whole square. And if you observe this carefully, you get this x square minus of y square plus 1 the whole square, and then plus 4x square y square equal to the x square plus y square plus 1 the whole square. If you write this 4x square y square and send this to the other side, a plus b whole square minus a minus b whole square is 4ab, 4 times of x square into y square plus 1. I'll just write that missing step. 4x square y square equal to x square plus y square plus 1 the whole square minus x square minus y square plus 1 the whole square. So yeah, so a plus b whole square minus a minus b whole square is 4ab. Now if you open the bracket, the 4x square y square equal to 4x square y square plus 4x square. This get cancelled, and x square equal to 0 and x equal to 0. When x equal to 0, that's purely imaginary, lies on imaginary axis. So therefore conclusion, Z lies on imaginary axis. So if you try to improve this information given, you can write Z1 bar equal to minus I Z2 bar. Just to get the information in terms of Z1, take the conjugate on both sides. Z1 bar whole bar equal to minus I Z2 bar the whole bar. This is Z1 equal to conjugate of minus I into conjugate of Z2 bar. The property is mod Z1 Z2 is sorry conjugate of Z1 Z2 is equal to conjugate of Z1 into conjugate of Z2. So the Z1 equal to conjugate of minus I is I, conjugate of Z2 is Z2 whole bar, Z2 bar whole bar is Z2. So you got Z1 equal to IZ2. So when you get Z1 equal to IZ2, suppose Z1 equal to R cis theta, which is actually R e power I theta. So the Z2 equal to I into R e power I theta. Basically, I is e power I pi by 2. So this is R e power I theta plus pi by 2. So the argument of, we don't need to write all this directly by looking at this. So Z1 is here, suppose. This is Z1. And Z2 is obtained by rotating it about the origin by 90 degrees. The length will remain the same. That's what the meaning of Z1 equal to IZ2. So the magnitude remains the same, only the argument will be increased by pi by 2. But they are given the argument of Z1, Z2 equal to pi. So the formula for argument of Z1, Z2 is argument of Z1 plus argument of Z2 equal to pi. But argument of Z2 is 90 plus argument of Z1. So the argument of Z1 plus argument of Z2 we need. So the Z2 equal to Z1 by I. So that implies argument of Z2 equal to you can write Z1 plus, oh, sorry, I think I actually messed it up here actually. Z1 is coming from adding pi by 2. So Z1 is equal to Z2 equal to, oh, I did it wrongly. Like I just messed up with the order. I took Z1 in place of Z2 and Z2 in place of Z1. It's okay. So you get Z1, you need to take Z2 equal to R e power I theta, and you get Z2, Z1 equal to R e power I theta plus pi by 2. Basically, this is Z2 and this is Z1. So the Z2 argument is argument of Z1 minus pi by 2 equal to pi. So that implies 2 times of argument of Z1 equal to 3 pi by 2. That implies argument of Z1 equal to 3 pi by 4. Okay. So as the question asked is to calculate the argument of Z1 and Z2. So just consider the given equation in square on both sides. Then what it becomes, Z1 plus Z2 the whole square becomes Z1 square plus Z2 square plus 2 Z1 Z2 equal to the RHS is Z1 square mod Z1 square plus mod Z2 square plus 2 times of mod Z1 into mod Z2. So this Z1 square and mod Z1 square, it won't work in that way in LHS. So you need to, RHS is fine, but LHS what you need to write is Z1 plus Z2 into Z1 plus Z2 bar you need to write, because mod Z square is Z into Z bar. RHS is anyway that, so no worries. So Z1 plus Z2 into Z1 bar plus Z2 bar equal to this. RHS remains the same. Now if you open the bracket, Z1 Z1 bar plus Z1 Z2 bar plus Z2 Z1 bar plus Z2 Z1 Z2 bar equal to the RHS same. Mod Z1 square plus mod Z2 square bar doesn't matter, plus 2 times of mod Z1 to mod Z2. So this and this get cancelled, and this get cancelled. Now you can cancel. Now Z2 bar plus this. So actually this Z1 Z2 bar plus, if you take a bar of it, so the Z1 Z2 bar, the whole bar, equal to the 2 times of mod Z1 into mod Z2. So a complex number plus its conjugate. A complex number plus its conjugate is basically the real part of it. Real part of Z1 Z2 bar equal to 2 times of mod Z1 into mod Z2. So in this way calculation is little, because anyway we need to convert this into polar form. If you convert this into polar form, so we couldn't avoid introducing the polar form. So the Z1 should be written as R1 e power I theta 1 and Z2 is written as R2 e power I theta 2. Z2 bar will be automatically R2 e power minus I theta 2. When you multiply both of them, R1 R2 e power I theta 1 minus theta 2. So the R1 is basically the mod Z1. R2 is mod Z2. Only real part in it, right? Real part means only the cos part. Cos of theta 1 minus theta 2 equal to 2 times of mod Z1 to mod Z2. And of course, when you take the real part, 2 times of that you get. The 2 times of, and then you write this, what you get, the 2 times of real part. That's what you get in the formula actually. So that 2 will come and 2 get cancelled, and this get cancelled, and then you get cos of theta 1 minus theta 2 equal to 1. Cos 0 is 1. Theta 1 minus theta 2 equal to 0. So theta 1 equal to theta 2, and that's what they're asking us to prove. Argument of Z1 equal to argument of Z2. We couldn't avoid taking the polar form. So instead of doing this calculation in Cartesian form, I mean this Z1, Z2 form, and at the end substituting Z1, Z2 in terms of polar form, from the beginning also you can take Z1, Z2 as R1 e power I theta 1 and all, and then do the calculation completely in terms of polar form also. The information that they are given mod Z1, mod Z2, mod Z3 is equal to 1. Because you need to find mod Z1 plus Z2 plus Z3. What we can do is we can try to get the relation between Z1 and 1 by Z1. Of course, that is 1, but like if you see that mod Z1 equal to 1, that implies mod Z1 square is also equal to 1. That implies Z1 into Z1 bar is equal to 1. That implies Z1 bar equal to 1 by Z1. So because this information to improve and then try to get that in terms of this. So similarly, you get Z2 bar equal to 1 by Z2 and Z3 bar equal to 1 by Z3. So the benefit by getting this is the second information that we're having 1 by Z1 plus 1 by Z2 plus 1 by Z3 can be written as 1 by Z1 means Z1 bar plus 1 by Z2 is Z2 bar, 1 by Z3 is Z3 bar equal to, so this, yeah, you can write this as using the properties of conjugate, you can write this as this is Z1 plus Z2 plus Z3, the whole bar you can write. And you know that the conjugate magnitude and then the original complex number magnitude will be the same. So the magnitude of this and this both are same, but it is given as 1. So this is also equal to 1. The answer is 1. So the information given is Z lies in interior on the boundary of the circle of radius 3 and center minus 4 comma 0. You see this minus 4 comma 0 is here. The circle with center that and the radius 3 is this. So 3 means minus 7 minus 1. So this is circle and then this point lies in interior of that. So the greatest value of mod z plus 1 means, so this complex number, all these complex number are added by 1. So when you add 1 to the complex number, the real part is increased by 1. So the new z, like the z plus 1 that we are going to get is here, 1 unit is increased. So for the z plus 1, the center also will change and the radius will remain the same, the position will change. So these are all the points. So interior to the circle are the z plus 1 points. So z point is in interior of the blue color circle and z plus 1 is a point, arbitrary point and interior of this black colored circle. The greatest value, greatest and the least value of mod z plus 1 is what they're asking. So you can clearly see the least value, that's nothing but the distance from the origin to that point. The least value of mod z plus 1 equal to 0 and greatest value of mod z plus 1 is 6. You can clearly see that the greatest value is the diameter of the circle. This is the general form of the circle. Z minus the center, the distance from Z and then center is less than or equal to the radius, the 3. That's the disk actually. Disk in the sense circle along with the interior of the circle. So using this known equation from the given information to get the value of mod z plus 1, you can write mod z plus 1 as mod z minus 4, z plus 4 minus 3. And you have a property mod z1 plus z2 is less than or equal to mod z1 plus mod z2. So you can write this. So equation 1, if you add 3 on both sides, so the mod z plus 4 plus 3 is less than or equal to 3 plus 3. So this value is less than or equal to 3 plus 3, which is 6. So the maximum value of mod z plus 1 is 6. And the minimum value of this is clearly 0, the least value. You can get it from the diagram. So to find the least value, what we can do is we can take the circle equation z plus mod z plus 4 is less than or equal to 3. And as z equal to minus 1 lie on the circle. So z equal to -1, so z plus 1 equal to 0. Now lie on this, z plus 1 value is 0. So that implies mod z plus 1 equal to 0 is possible. So the modulus of z plus 1 is 0, and modulus can never be negative. So hence, therefore, the mod z plus 1 is greater than or equal to 0. So greater than or equal to 0 is well known for us, but our doubt is whether 0 is possible or not. Yes, 0 is possible, so that we can call that as a least value. Therefore, the least value equal to 0, and this after getting this greatest value equal to 6. So this is from the diagram, and this is like solving the inequalities and all. We can get the least value, the greatest value. The question asked is to locate the points for which mod z is between 3 to 4. You can clearly see that all the points for which the distance mod z less than 3 means all points which are interior to the circle with radius 3 and center origin. This is what mod z is less than 3 means. Mod z is less than 4 means the circle with radius 4 and center is origin. But what they're telling in this circle, this is such that mod z should be greater than 3. So that means outside the circle, and less than 4 inside the circle. So basically, this ring is what this locus of this point. So what we can say that the points are in this ring. The points are in middle of this, the distance from this. So the points are outside the circle x square plus y square equal to 9, and inside x square plus y square equal to 16. So that's what locating them. Or you can write, if you directly write the algebraic calculation, then 3 is less than root x square plus y square is less than 4. And all are positive, you can square throughout. 9 is less than x square plus y square is less than 16. Algebraic calculation also you can get. Diagrammatically also you can try to understand the logic behind it.